Good Monday. So, our continuing quest to understand, one of the things science is used for is measuring abundance. Abundance is how much of something is there. Specifically to an elemental chemist, it's the abundance of elements and isotopes. Okay, isotopes are relatives of the elements that they speak to, or that they're attached to or related to. What we do is we measure how much of something is on our planet. If you go into a periodic table of elements, you should be able to find isotopic abundance information for elements. That is how much of something is in the environment and the atmosphere around us. We do this for CO2. We have records. We've been able to measure this. We can go back and measure historically using very sophisticated techniques the abundance of CO2 in the atmosphere. This is a part of the CO2 conversation scientists are having and the information that they use. When those studies are done, now understand you're looking for parts per billion, parts per trillion, and beyond even that, what we are capable of measuring. That is the needle in the haystack type of analogy. How do you find that? What is it? What kind of needle is it? Is it a plastic? Is it a metal? So it's complicated. I have seen as long as 2 years of they've basically analytics applied to get the numbers and make sure they're correct, so that scientists can talk among themselves about what it means and maybe share with us. Because you can't just draw people into the beginning and the middle and the end of these are very, so who do you trust when you go look at elemental numbers? So this is something somebody else brought up, saying that an isotope has been around forever. The challenge is they're right. They are absolutely correct. We have known about isotopes for, I think, over 100 years now. Now, in human lives, that's what, 4 generations? 5 generations that we have really known that it's been public. There was work before this. We had ideas about this. We just got better and more precise at measuring, at understanding, at putting these pieces together. So the puzzle is all of the elements that nature has to offer us and what we can do with them. The periodic table shows 100 and whatever elements. There's some that don't exist, but on paper, really. But we're confident enough they're there and we can use them. We can show their effects that we've proven it. It's not a question. It's not. It just is our common evolution, the age of our planet, our understanding of all of this goes. It's there. So isotopic abundance. There are layers to this abundance thing. There is elemental abundance. We went back and we looked at chlorofluorocarbons decades ago, did very detailed studies on the chemical process CFCs go through in the atmosphere, the abundance of those chemicals in the atmosphere and what difference that makes, because these are chemical equations that have multiple variants. If one changes, another will change. So 2, 3, 5 variables, 10 variables in these equations can change. If we can measure and predict the change, we can predict outcomes. We can predict risk and harm. This is how the sciences work, putting all these pieces together. So how we understand what elements, what compounds are in our environment that are man-made, that we have never in the billion year history of evolution encountered in discernible amounts. So you have to have this time clock, this deep time clock to put these pieces together. You have to have some understanding of the slow, methodical process that occurred over billions of years to get us right here, right now, because that's how it works. That's what we have shown through our research and understanding and our ability to comprehend and put it together. We're amazing things in ourselves. To worship ourselves is foolish. It gets us nowhere. You don't live by yourself. Nothing you're sitting on probably was made by you. The materials didn't come from your neighborhood. The food on your grocery stores came from somewhere else. To think you're going to survive is a good idea. How you want that survival to be, I'd say, one for all and all for one. Shallow, simplest models. Well, there's a ramble around abundance, isotopic and elemental abundance. We study this, we do this, we know about it. It impacts our current and future health. That we know.